Hi, here's another video that I've created for you to talk a little bit about Ethernet MAC addresses. So in addition to Ethernet MAC addresses, we will also talk about the different types of addresses that you will see within an Ethernet frame. And with that being said, we'll also need to talk a little bit about IP addressing too. So let's go ahead and get started because I have quite a bit to go over with you. So looking at the screen here, we have the hexadecimal numbering. So why do we need to learn about hexadecimal? Well, hexadecimal addresses are used to represent your Ethernet MAC addresses. Okay, so MAC addresses are layer 2. They're also represented in IP version 6 addresses. So we haven't learned about IP version 6 in your class yet, but that is coming. So let's look at this chart here, and I'm also going to show you something that I've referred to in the past. So this chart here shows us the 8 bits in a byte that's used to represent an IP address. So with this, we see our 8-bit positions, and you have the 2 to the 0 power equals 1, 2 to the first power equals 2, 2 to the second equals 4, and so on. So if you were to take an address in binary, the 1, 1, 0, 0, 0, 0, 0, 0, add the placeholders of 128 and 64, it would equal 192. So 192 converted to binary is this number, 132.3. IP addresses or 32-bit addresses are represented in 4 bytes. So this is what we use for binary and decimal conversion. Well, we can also use the same information when we're looking at hexadecimal addresses. So I'm going to flip back over to that. So if our decimal number is 0, it's converted into binary at 4 zeros. Okay. So for hex numbers, notice we use 4 placeholders. So showing you this is just going to be this right hand section. So these rows right here are all we're going to use for hex because it's a base 16. So if you add these values together, you would have numbers 0 through 15. Okay. So going back to this, decimal of 0 equals 4 zeros, and in hex that would be a 0. The decimal of 1 in binary would be 0, 0, 0, 1, and hex would be a 1. Okay, now do the same up through number 9. Well, here's where it changes, beginning with 10. So 10 in binary is 1010. That would be this would be the 1 placeholder. The next one would be the 2, 4, and 8. So 8 plus 2 is 10. Well, since there's only one spot available for each letter within hexadecimal, we have to go to numbers. So starting with number 10, it would be represented as the letter A. 11 would be B, 12 is C, 13 D, 14 E, and 15 would be represented as letter F. Here's another chart showing you the binary decimal equivalents if you're looking at an entire byte. Okay, so 0 would be all zeros and double 0. So you put 2 numbers together. If you would have 0 and 1, okay, so this is 4 zeros here, break it in half. This would be 0, 0, 0, 1. So this left number is 0, the right one is 1. Okay, let's go down to something like, let's look down at this 192. So 192 in decimal is this number. 128 and 64 equals 192 because you're combining the entire thing in binary. But you're not doing that with hex. You separate these. See where that little separator is? So this would be the letter C. The right hand side would be 0. So why is it C? Well, 8 and 4 would be 12, which is the letter C. So C and 0. And that would represent your hexadecimal numbers. if you're looking at an Ethernet address, it's going to be a 48-bit address. Now that 48 bits, if you split it right down the center, the first 24 bits will be called what we consider the OUI, Organizational Unique Identifier. That is the vendor. So who produced it? Cisco or Dell or whoever actually made the NIC that you're using. On the right, the last 24 bits are the vendor assigned number for that NIC. So however they decide to number theirs. The first 24 bits says here's where it came from, who created it. Second 24 actually identify the NIC itself. So 6 hex digits here, 6 here. This would be an example. If you put it all together, that's the entire MAC address for that NIC. So how do devices use these? Well, that depends on the frame forwarding method that is used. In some ways, they would actually, some devices, they forward the entire frame and read it and send it. Some devices will choose to just look at the destination address and then forward the frame. Okay. So the cut-through method is the one where they would actually look at the destination address, whereas the frame or store and forward method would be the frame forwarding method, where it would read the entire frame itself. And they would read the cyclic redundancy check at the end before forwarding it. If you were to do an ipconfig/all on your PC, then you would actually see the physical address listed right here. So this is showing up in orange. That would be the physical address. Okay. Now there are different types of addresses. So you have unicast, multicast, and broadcast addresses. So to understand that, I'm going to flip over to a document that I created. Now I want to go over a few IP basics with you, because this is extremely important that you understand the IP basics, because we're going to be using this information not only here to be able to identify what types of frames that you're actually looking at, but it's also going to be very beneficial when you start understanding more about network addresses. Okay, so here's a little handout that I created. So this is IP addressing, makes it possible for data passing over the network media to find its destination. Okay, so this information is broken down into the bit level or the binary level, like we were just looking at, so that it can be understood by the computers when it's used on layer 1. So if you're looking at their dotted decimal notation, you'll notice a network number and a host number. So a class A address, if you look at the range in the first octet of the address, you would see a set of numbers. So the range in that first octet would be 1 to 127. Okay. If you're looking at the bit position of that, it would be a 0. Okay, and this is the structure. So the number in the first octet would be the network number, beginning with 1 to 127. The next 3 octets would be the host numbers. So those would be the numbers you could assign to any device. The network number you can't change. You assign that number. But the other 3, as a network administrator, you would be able to assign however you see fit within your organization. A class B address would be the 128 to 191. And this is how the bit position would start in that first octet. Okay. And by that, I would mean if I were to go down here and take an address, and that range is 128 to 191. So if I were to have a 1 in this first bit position, I had a 1 here, and then if I were to have a 0, then the highest value that I could actually have would be 191. So again, that range would be 128 to 191. That's why it would be starting out with a 1 and 0. And again, that's just converting the values that are there. That would also mean that the first 2 octets would be assigned as the network number. Okay, so they stay the same no matter what. The second 2, or the last 2, would be assigned as your host number. For Class C, 192 to 223 would be the Class C range. And again, if you were to convert in binary, you would have 110 as the first 3 bit positions. The first 3 octets are assigned as the network number, and the last one would be the host number. Class D is not assigned to devices that travel around on the internet. They're used for multicasting. So this information is sent out to a group of devices, and they would be in this range right here, 224 to 239. That's how you would identify them as multicasting. Now, not all of these numbers are used. So 127 is used for loopback or internal testing. And there are special address types here, which we're going to talk a little bit more about in just a minute. But you heard me referring here to network numbers and host numbers. So let me talk a little bit about that. So any IP address that contains binary zeros in the host portion of the address is reserved as the network address. Now the network address, that's just the first number that's assigned in a group of addresses or a range of addresses. It's used to identify that entire block. It can't be assigned to a particular device, but it is used to identify all the devices within that group. So the best example I can give you for that would be if you have an address list that you create. So you create that on your phone or in email, and you identify a group of people. So that's not actually the address or the telephone number for that group of people, but it's how you would identify them. Example of that would be the network address, because you can't assign that number to any device. It just identifies the group. As a matter of fact, if you tried to type in the network address on a Cisco device or even on your PC, it wouldn't actually let you do that. It would flag you and tell you it's the network address and you couldn't use it. Same thing with a broadcast address. So a broadcast address is a device that contains ones in the host portion of the address. That would be considered a broadcast address. And broadcast addresses are used to send data out to all the devices within that network. Okay. So that address cannot be assigned to a particular device. So your network address is generally the lowest address within that range, whereas the broadcast address is the highest address. To give you an example, if you're looking at a Class A address, you have a network address of 192.0.0.0, so zeros in the host portion. Well, then 192.255.255.255 would be the highest number you could possibly have in that range. So that's why that would be a broadcast address. So all zeros or all ones if you're looking at that in binary. Same thing with Class B. So 192.168.0.0 would be the network address. The broadcast would end in all ones. Same thing with C. You have 192.168.16.0 or 192.168.16.255. So 0 is the smallest, 255 is the largest. So network addresses, you'll see them end in even numbers because it's zeros in the host portion. And if you look in binary, that's a 1. That bit position is a 1. So that's why you'll see broadcast addresses will be odd numbers. Okay. So there will always be odd numbers. Network numbers will always be even numbers. If you see anything different than that, then that would not be correct, or you did something wrong in your calculation. Okay, if you're converting your addresses, for example. Now, when you're looking at these addresses, there are some private addresses within these ranges that I gave you earlier. So if Class A is 1 or 0 up to 127, okay, if you're looking at that They're private numbers. For Class A, it would be 10, anything in the 10 range, 10,000 through 10,255, 255, 255. Okay, so what does this mean? Well, you can assign these addresses inside your network, but they are not routable by a router to the outside world. Okay, so you can use these for a variety of reasons. Okay, say you're assigned to Class C, but you want a larger number of addresses within your network, so you might want to use a Class B or a Class A. You have to actually convert that to a public address using network address translation or NAT to go to the outside world, but that can be done. So that's kind of beyond the scope of this class really, or right now, but just know that you can do that. So you can use these internally, kind of like you could use a nickname in your house, but you wouldn't go to the DMV or you wouldn't go to the Social Security Administration and actually try to use whatever your nickname is. You want to use like your legal name. So to the outside world, you want to show the address that is assigned to you, your public address, but you can use your private within your network. So for Class A, it's anything in the 10 range. For Class B, it would be 172.16.00 through 172.31.255, 255. And Class C, 192.168, anything. So those are your private addresses for each class range. Now, getting to that Class D, I'm going to scroll up here. So I mentioned this range for multicasting. So your multicast addresses are meant to group devices together. So if an address starts with 224 to 239, then you know that is a multicast address. So 224 to 239. And again, broadcast addresses are defined as having all ones in that host portion. So unicast, multicast, and broadcast addresses. Okay, so broadcast addresses, all ones, or in this case, if you have a 1 in every placeholder, equals 255. So if we were looking at this diagram, listing or showing you a unicast MAC address, okay, so you see the destination and the source MAC. Well, look at the source and destination IP. So these are just regular addresses. Notice they're private addresses, but they're regular addresses. That's a unicast address. It goes to one device. But look at your broadcast address. So using what I just showed you, you see this F? Okay, if you'll remember from looking at your MAC addresses, all ones would be an F. Okay. So that would be all ones. Also, you could look at it here if you remember the knowledge that I just shared with you. 192.168 is a Class C. 1, and then if you remember the structure, N, 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 H. So if this is your host number and it has all ones, or the binary equivalent of all ones, when you convert, again, that's a destination broadcast address. That's how you would pick that out. If you were looking at a multicast, well, that should be easy. Remember your range? Okay. So look at the 224. That falls within the range. Okay. So 223 was the beginning range. This is 224. Okay. So up to 239. And also this will usually be the same. 01005E is a multicast for MAC addresses. Alright, so that's the end of that section, and I hope that helped you a little bit with your addresses, your Ethernet addresses and IP addresses.